Reliability evaluation method of intelligent transportation system based on deep learning. Abstract. Urban road reliability analysis is an important part of traffic condition analysis and research in recent years. The research on road network reliability can provide strong information support for the control, induction, optimization, and planning of intelligent transportation systems. In this context, a reliability evaluation method of intelligent transportation system based on deep learning is proposed. Using the Delphi method to select evaluation indicators and build an evaluation index system, the AHP method and factor analysis method were used to calculate the comprehensive weight of the indicators. Based on the deep belief network in deep learning, an evaluation model is constructed. The reliability index is calculated, and the degree of reliability is judged. The test results show that the intelligent transportation system is applied in 9 different administrative regions, and the obtained reliability indexes are all above 1.0, indicating that the reliability of the intelligent transportation system is high. Keywords: deep learning, intelligent transportation system, evaluation index, AHP method, factor analysis method, reliability evaluation. Introduction. The smart transportation system is a basic, leading, and strategic industry for urban development and construction, and an important service industry that meets the need of urban life and production. The transportation system in the central area of the large city is the lifeblood of the entire city development and the core to ensure the normal operation of the city. A stable, efficient, and reliable transportation system is not only the basis for travelers to achieve their travel goals, but also the ultimate goal of urban traffic managers and builders. As socialism with characteristics enters a new era, my country's urbanization process continues to accelerate, and the number of large cities continues to grow. Relevant data show that in 2013, there were 7 cities with urban populations exceeding 10 million in my country. In addition to Beijing, Shanghai, Guangzhou, and Shenzhen, there were Wuhan, Tianjin, and Chongqing. Urban populations were between 5 million and 10 million. There are 11 cities, namely Chengdu, Nanjing, Foshan, Dongguan, Xi'an, Shenyang, Hangzhou, Suzhou, Shantou, Harbin, and Hong Kong. As of 2017, the number of large cities with a population of more than 2 million in the central area of my country has reached 53, accounting for about a quarter of the number of large cities in the world. However, with the continuous expansion of the scale of cities, the contradiction between traffic supply and demand in the central areas of large cities has become prominent. The regional road traffic pressure has increased, and the traffic congestion in the central areas of large cities has become more and more serious. Due to congestion, the operational efficiency of the transportation system has decreased. The operating cost has risen. The travel time of traffic participants has been prolonged, and the traffic environment has deteriorated, which has seriously affected the normal conduct of various life and production activities in the region. Research on reliability of intelligent transportation system. The reliability of smart transportation system is getting more and more attention because significant travel uncertainty not only increases the difficulty and cost of individual travel decisions, but also reduced efficiency of the transportation system, affects the performance of the system, and even leads to the failure of management measures. Reliability is an important performance index of urban transportation system, and it is a probabilistic description of the transportation function of the system. It is not only affected by static elements such as road network facilities, but also more susceptible to dynamic random demands, which makes the uncertainty of reliability itself more difficult to describe. In many megacities, frequent traffic accidents and road maintenance and other temporary events and natural disasters and other emergencies require the rescue vehicles to arrive at the accident site quickly and in a timely manner under the premise of satisfying accessibility. It can be seen that reliability is different from the general indicators used to describe the operation status of the urban transportation system. It interrogates short-term and long-term indicators. It not only represents evaluation criteria, but also has policy connotations. It is a system performance indicator based on a broader basis and belongs to a multidisciplinary research field. Therefore, in-depth discussions are needed from different perspectives, such as transportation science, system science, computer science, economics, and behavior science. Clarify the influencing factor of reliability. According to the definition of the research object above, this subsection focuses on analyzing the components of the smart transportation system, laying the foundation for the following article to accurately grasp the urban traffic operation mechanism and find out the reliability indicators that affect the smart transportation system. The smart transportation system is mainly composed of 5 parts: traffic flow, road network, traffic management conditions, and traffic environment. Among them, traffic participants and transportation modes are collectively referred to as road traffic flow. The following will analyze the various components of the road transportation system in combination with the actual course of the traffic system in the central area of my country's large cities. Traffic participants. Traffic participants, including pedestrians, drivers, and passengers, and are one of the elements that make up the traffic flow in the central area of a large city. The dynamic and random spatial-polar distribution characteristic of traffic flow in the central area are mainly due to the uncertainty of the total amount of travel and the travel behavior of each traffic participant. Mode of transportation. Transportation modes include private cars, conventional buses, rental and online car hailing, and non-motorized vehicles, which are another major element of traffic flow. The complex and diverse modes of transportation in the central area, its operation mode, the travel proportion of various modes, and the transportation and the operation status are mainly affected by the travel behavior of traffic participants and the structure and the scale of road network infrastructure. Analytic hierarchy process. Subjective weight determination based on the analytic hierarchy process, AHP method. AHP is a widely used method for determining subjective weights. When using the AHP method to determine the subjective weights of the indicators, firstly, the hierarchical structure model between the target layer and the criterion layer is established, and the judgment matrix between the relevant factors at each level is constructed according to the data and the experts according to the scaling method. Then, the single level ranking and the total level ranking of each level are obtained. And then the consistency test is carried out on the judgment matrix of each level. When the ratio CR of the consistency index CI and the average random consistency index RI is less than 0.1, the judgment matrix has satisfactory consistency. Finally, the maximum eigenroot and the 8 vector of the matrix are obtained by the sum product method. Factor analysis method. Factor analysis is a method to simplify data processing and problem analysis. It can describe and express the information that contains almost all the data by means of dimensionality reduction with few indicators. These representative indicators are calculated by certain mathematical models. Moreover, in the subsequent analysis, it is necessary to consider the proportion of each main factor to calculate the comprehensive score of the factors. And the weights in the factor analysis method are also calculated and processed with the help of mathematical model and SPSS. Therefore, the disadvantage of artificially defining the proportion of factor is avoided, and the interference of human factors is eliminated, so that the results of factor analysis have higher objectivity and the distorted part is reduced. Evaluation model based on deep learning. Deep learning is a research direction gradually formed with the continuous development of artificial neural network as a special machine learning technology under development. Deep learning is still limited in academic circles, so there is no unified definition. Deep learning is a data-driven modeling method, which can be regarded as a machine learning method that performs unsupervised or semi-supervised machine learning method. Feature extraction through multi-layer nonlinear information processing units to achieve classification and prediction. Deep learning uses algorithms to parse labeled training samples and learn some potential patterns from the samples. Then, the complex data relationship is modeled, and the model is used to analyze and predict the samples, so as to better complete the required task. The core idea of deep learning is to establish a multi-level learning process, simulate the human brain for analysis, learning, and induction, and use the mechanism of the human brain to analyze data and solve problems. The vigorous development of deep neural networks solves the problem of insufficient representation ability of shallow network functions. In addition, the deep neural network solves the gradient disappearance phenomenon that occurs in the traditional neural network with increase of the number of network layers. Therefore, it will be the next development direction to introduce the reliability evaluation model of intelligent transportation system in combination with deep learning theory. This chapter takes deep learning as the basic theory and the deep belief network as the theoretical support of the evaluation model, and completes the reliability evaluation of the intelligent transportation system from the perspective of deep learning. Evaluation method testing and analysis. Research object and background. In order to verify the validity of the reliability evaluation method of intelligent transportation system based on deep learning, The main urban area of a city includes 9 administrative regions, covering an area of 5,473 square kilometers, and the urban construction land area is 595.03 square kilometers, an increase of 25.8 square kilometers, and increase of 4.5070 over the same period last year. Among them, the urban road land was 107.73 square kilometers, an increase of 7.1 square kilometers over the same period of last year. The resident population of the main urban area is 8.518 million, a year-on-year increase of 2.0070, making it one of the typical large cities. The city uses the smart transportation system for traffic scheduling and management in 9 administrative regions, testing the application performance of the evaluation method. Evaluation index system. According to the score given by each expert, the positive coefficient, authority coefficient, and the coordination coefficient of each evaluation index are calculated, and the results are shown in Figure 2. Comprehensive weight of evaluation indicators. The AHP method and factor analysis method were used to calculate the comprehensive weight of the indicators. Taking 3 areas as an example, the comprehensive weights of evaluation indicators are obtained as shown in Figure 3 and Table 4. Conclusion. The smart transportation system is the lifeblood of urban development and the core to ensure the normal operation of the city. A stable, efficient, and reliable smart transportation system is not only the basis for travelers to achieve their travel goals, but also the ultimate goal of urban traffic management and planners. To this end, a reliability evaluation method of intelligent transportation system based on deep learning is proposed. The following achievements are made. The intelligent transportation system is applied to different areas, and the system reliability is high, which proves the effectiveness of the method. It can maximize the rational allocation of existing resources and effectively explore the potential of the road network, which has great theoretical significance and application value for improving the level of urban traffic management and dealing with the hazards caused by sudden disasters and emergencies. In order to improve the accuracy of the system reliability analysis and evaluation results, the sensitivity of various indicators to reflect the actual situation, the degree of deviation of the indicator from the actual situation in the long-term change chain, and the relevant theories and practices at home and abroad should be taken into consideration in the future research, so as to put forward more in-depth and meaningful suggestions for improving the reliability of the transportation system in the central area of large cities. Thank you.